All right, today we're doing a public security disclosure. We're breaking down CVE 2025-54957. Now, this isn't some abstract bug on a server you've never heard of. No, this is a vulnerability in something you probably use every single day, the Dolby Audio Decoder. Yeah, the software that makes the sound on your phone and computer actually work.
So let me just ask you this straight up. Could a simple audio file, like a voice memo someone sends you, be enough to completely hack your phone? And not just your phone, we're talking about your laptop, maybe other devices too.
And here's the real kicker. We're talking about a hack that could happen without you ever, not once, pressing the play button, without you even touching your device. That is the really unsettling part of what we're digging into today.
So that brings us right to the heart of this thing, a silent audio attack. We're going to unpack what the security world calls a zero-click threat. And believe me, it is one of the scariest kinds of exploits out there. So what is a zero-click RCE? Well, RCE stands for Remote Code Execution. It's basically the holy grail for an attacker. It means they can run whatever malicious code they want on your device from anywhere in the world without you having to click a link, open a file, do anything at all. We're talking spyware, data theft, total device takeover.
So check this out. This is how it actually plays out on an Android phone. First, an attacker sends you a specially crafted malicious audio file. Then your messaging app, just trying to be helpful, automatically starts processing that file in the background to create a little preview or maybe a voice-to-text transcript. And boom, that's it. The vulnerability is triggered right then and there. You might not have even seen the notification for the message yet.
Okay, so the big question, right? Who's at risk here? Are you affected? Let's take a look at just how wide the net is for this particular vulnerability.
The problem, the actual weak link, is buried inside a piece of software called the Dolby Unified Decoder Component, or UDC, specifically versions 4.5 all the way through 4.13, and this little component is everywhere. It's baked into operating systems and devices all over the world to handle high-quality audio.
And this is so important. This slide perfectly shows why context is everything in cybersecurity. When this bug was first made public, the official score was a 6.5, which is just medium. Why? Well, because on a desktop computer, you usually have to click on the file to open it. But on Android, where the phone processes it for you automatically, the exact same bug gets upgraded to critical. It's a huge difference.
So listen up, because this is the part that matters most. On Android, if your security patch is from before January 5th, 2026, you are vulnerable, period. On Windows, you need to have the updates from October 2025 or later. And for you Apple folks, here's the interesting part. The vulnerable code is technically there on macOS and iOS, but researchers found that other security checks on those systems make it really, really hard, maybe even impossible, to actually exploit right now.
Okay, time to get a little nerdy. How in the world does an audio file take over a phone? Well, it all boils down to a classic, tiny, but absolutely catastrophic programming mistake called an integer overflow. The original technical report puts it perfectly. It says the calculation for how much data to write can overflow. And when that happens, the space, or buffer, that the computer sets aside ends up being way too small.
You know what? To make this super simple, let's use an analogy. Think about one of those old-school mechanical odometers in a car, the one that physically clicks over to track the miles. Imagine it's about to hit its absolute limit. So you're at 999,999 miles. What happens when you drive one more mile? It doesn't just jam or stop. All the numbers roll over and it wraps around, right back to all zeros. It goes from a huge number to a very small one, just like that.
And that is exactly what's happening inside the Dolby Decoder. The malicious audio file tricks the software into calculating a number that's so big, it can't fit in the space the computer has for it. So just like the odometer, it wraps all the way back around to a tiny, completely wrong number. This kicks off a little chain reaction of disaster. First, the number overflows. Second, based on that tiny, wrong number, the program sets aside a ridiculously small amount of memory. And finally, it tries to stuff the entire, large chunk of audio data into that tiny little space. Of course, it doesn't fit, so it spills over and starts overwriting whatever was next to it in memory, which could be anything, including the instructions that run your phone.
Okay, enough about the problem. Let's talk about the solution. This is the most important part of the whole disclosure, the actionable intelligence you need to stay safe.
For every single Android user out there, this is the number. This is what you need to look for.
Go into your phone settings right now and check your security patch level. It needs to say January 5th, 2026 or a later date. If it does, you're good. You're protected from this. Look, your first, last, and best line of defense is always going to be the official patch. So for Android, get that January 2026 update. For Windows, make sure you've installed the cumulative updates from back in October 2025. This is how you get the fixed version of the Dolly software onto your device. Now, if you want to add some extra layers of security, especially on a desktop, you can. Turning off automatic media previews in your File Explorer or email is a big one. That gets rid of the main attack vector on Windows. And for the developers out there, things like strict data validation and sandboxing your media players are really powerful ways to harden your systems.
And finally, I think it's really important to pull back the curtain and show you the story behind the patch. This is how a bug goes from a private discovery to a fix that lands on millions of devices. So this whole thing started way back in June of 2025. That's when researchers at Google's Project Zero found the bug and privately reported it to Dolby. That's step one. By September, Dolby had a fix ready for its partners. In October, Microsoft rolled out the patch for Windows, and the bug became public knowledge, but with that misleading medium rating. It wasn't until January 5th, 2026 that the official Android Bulletin came out and correctly labeled it as critical.
And this right here, this is the danger zone. A working exploit, a proof of concept, was out there on GitHub in October 2025. But the required patch for the most vulnerable platform, Android, didn't arrive until January 2026. That's almost 3 months where a zero-click bug was known to the world before the fix was widely available for mobile users.
This whole process, this timeline, it's a perfect example of what we call coordinated vulnerability disclosure. It's a really delicate dance between giving companies time to build a fix and letting the public know they're at risk. It can be messy, but it is an absolutely essential process for keeping our digital world even remotely safe.
And all of this leaves us with one last, pretty sobering question to think about. This bug was rated medium in one situation, but critical in another. So it just makes you wonder, how many other seemingly low-risk bugs are out there right now, just one small context change away from becoming the next major global threat?